One second. Actually, this is a site, a very beautiful site where we can start, click on get start, and here we can start with audio project. And here, like through my mic, I can upload uh, some sample. From this particular example, you will understand that for machine learning, the main thing is data. And that data maybe come in the form of some column-based data, that is structured data, and some data maybe in the form of images or in the form of videos, and later on how machine learning algorithms they understand it, and we train our model, and based upon that we conclude something. So here I'm just going to classify a noise into category background noise, and another class, let's say clapping. So first of all, right now I'm recording it for background noise. So right now it's recording for 20 seconds, and it will be considered as a background noise. So whatever is happening, so it this particular class falls in the category of background noise. So it is recording it, and we are continuously speaking, and it will take 20 seconds. Now it is having this data. You can see this data is there. So this is we have recorded this particular data, sound data, noise data for 20 seconds. Now I'm going to record a different kind of sound for second, like clapping. And here I'm pressing it and recording for like this. Again, I have to give it more data. So again, it is required. So this is how we are extracting it, and then we are training the model. Some error is there. Okay, this data is less. We need more data. Again, this is 6 now. So I'm having the sample with me. So I'm training my model. So if it will take little time. So this is training the model, and based upon this, see right now I'm speaking something, and it is classifying the sound in background noise. So this is background noise right now. The moment I'm clapping it, it is showing 100% this is sound of clapping. So we are using machine learning in in different kind of problems, like if we are talking about forest, and to identify the voice of different kind of creature over there. So machine learning is helping over there. Even though like sound of vehicle, we can understand that which vehicle is moving around. Even though when you are using your machine and you're deploying over there IoT based sensors, and you are observing the noise, and you can understand which particular machine is giving this kind of sound, and then they can immediately approach that particular machine. So this is a small example I was showing over here, and this is totally based upon data. So I'm just going to show you something. We're having a different kind of data which will help us. So here I'm going to show you first of all a data. You can see here, this is column-based data, which is structured data basically. So this is column-based data, which is having some labels. Okay, And here you can see this is our basically, you can say this is our y, or you can say output, which is relying on different parameters. And you can say these are the parameters basically: area, ed, energy, ss, residual length, and pair number. Okay, these are the, further you can say y, like in your linear equation, y equal to mx plus c. So you can have number of x over here, and based upon that we are observing, we are calculating a value that is your y. So, and from this particular data you can understand we are having a data which is see, this is a real number kind of data, this is a discrete data. So we are having two kind of data: continuous and discrete, or you can say nominal data. Like in case of nominal, you can classify it in something like whether it's a sunny day or cloudy, or kind of whether it's temperature is very high or low. So that kind of you can depict by 1, 2, 3 number, like whether email is spam or not, 1 or 2. So you are having that kind of discrete number, and the value which is coming continuous, that is your real value basically. So real value is having the scope in like predicting, like in case of agriculture, predicting yield, predicting rain, predicting weather. So all that, like weather is coming in 40 30 45.7 centigrade temperatures outside, and today rain is, we are expecting it will be 6.2 millimeter. So that kind of prediction which is coming in this kind of then it is comes under data which is in the form of real. And when we say that like we are taking the opinion of person that do likes tea uh, like very much normal or don't like it, so you can classify it in three kind, nominal in three kind of 1, 2, 3. So I hope you are able to understand. So let's begin. What is machine learning? Okay, the overall agenda will be that introduction to machine learning, practical uses of machine learning, and we'll take some cases and we'll understand how in machine learning we are also using some absolute error. We are also accepting error when we are talking about fully automation and machines are dealing with manufacturing, predicting something. In that case, we have to accept little bit value and consider it equivalent to 100% kind of, so that we can take a decision properly. And I will demonstrate in front of you how we are going to do it, and how companies like Bosch, Tesla, those are automobile company, or even like GE, all they are also using machine learning in their industry 4.0. We'll also understand the concept what is industry 4.0. So first of all, let us understand machine learning, and we'll demonstrate a little bit it and how it is having its application in industry 4.0, that we'll also discuss. So already we have seen this teachable machines. So now basic idea of machine learning. So first of all, we're having experimental data. I have shown you some data set. And even though I'll also demonstrate in front of you noisy data, I have created some noisy data. Also have created data for clapping. So that is my experimental data. And then the main thing is build a machine learning model. And machine learning model is purely depending on data analytics kind of skills is required over there. Like if you're a good statistician, like how to resolve a simple linear regression equation, or so similar kind of machine learning model we are developing, and which is going to help us in uh, predicting something, in classification, in clustering as well. So ultimately, we're having a data set. Then we are applying, we are building a model. I have already demonstrated in front of you. And lastly, we are able to predict something. So in every day we are using machine learning, we are observing it. So when you're receiving any email, so you're finding that email in your email box, or you may also find email in your spam. So whether email is spam or it is entitled, so there we have like companies like Google, they have developed that kind of algorithm where they identify whether this email is coming from a known person and you're also aware about him and he's sending something you, then it will that email will be delivered into your inbox, otherwise it will send to the your spam. Similarly, so this is related to classification. You are using uh, machine learning every day, and you're also observing that classification of email is happening with the help of machine learning. So now, when you're watching song on YouTube, and once you listen a particular kind of melody, it is recommending you another kind of melody. So based upon your taste, they are suggesting you another. They are predicting that you're liking, and accordingly they are recommending you that this song is suits your personality, and you can enjoy this song. So this is how they are, based upon previous data, they are correlating that data with your taste, and then they are recommending something. Then when we talk about clusters, as soon as you are typing something on Google, and they are showing you bunch of information. Like if I type in Google right now, okay, Google, if I'm typing a role of machine learning in 4.0, so it is showing me so bunch of information will come over here, and this is a, you can see here, this is a group. They have grouped many things over here. I can see videos, I can find out different kind of research article, and I can find different kind of news on this. Okay, if I'm clicking on news, I will have bunch of news. If I want to click on images, I will have the bunch of images as well. So this is how they are using clustering. So there is some story behind it, and that is purely a story related to machine learning. Based upon that, we are able to find the clusters. So again, in daily life, you are capitalizing machine learning in case of like in the form of clustering, but you we are not aware about that it is clustering. It is not machine learning, but we are finding a bunch of images. So more example, like already talk about email is spam or not, and daily you are doing a lot of banking transactions, so credit card, so that is fraud or genuine, that is also being classified based upon that. In healthcare, we are also diagnosing diabetic or non-diabetic, cancer or non-cancer. Gene classification is also happening nowadays. So now we are talking about what is machine learning. Simple definition of machine learning is it's a branch of AI that gives computer to learn without being explicitly programmed. And the simplest definition is a branch of AI about to construct a system that learn from data. So the whole game is about data. But if we put it in the mathematical kind of form, in what was in 3D, professor was asking what do you mean by machine, and then he was saying fan is a machine, this and that machine. So early definition was related to the very simple way of understanding the concept. But if we talk about particular kind of definition, then actual definition is a computer program is said to be learned from experience E with respect to some task T and some performance measure P. If its performance on T as measured by P improve with experience E. So this is how you can say that this is a machine learning. So based upon uh, you can say experience and the performance P on a particular task. If you're doing it again and again, again and again, so every time you will find a delta improvement in that, and slowly you will like a person or machine, it will behave like an expert of that particular domain. So further, if we talk about classification of machine learning, so we're having supervised learning and unsupervised learning. So in supervised learning, that we're having data in labeled form right now, shown you Excel file, the data which in column form and having some name in that particular column, a category or feature. So if it data is coming with some features with some label, that data is entitled for supervised learning. And in supervised learning, again we're having two category classification. So that is classification is here we are using discrete kind of it is giving us discrete value basically. In classification, we are having yes or no, email is spam or not, patient is diabetic or not, or transaction is fraud or that. So that kind of classification is happening. Loan, should we banker give the loan or not, accept the application of a loan, who a person who's trying to avail loan from a bank, so his application should entertain or not. So that kind of uh, predict discrete valued output comes under classification. And other side, when we're having a label data and we talk about regression, so here we predict the real valued output. So could you please write down in chat box an example of regression related which we are observing in daily life and already have speak about it. Please write in chat box related to regression. Example of regression. It is related to real value. You can type in chat box. Please let me understand how many people are getting it or not. Prediction of house price. Very nice, Sashi. Thank you. What else? Do you think that if we are predicting yield of a particular agriculture or yield of a particular crop is a real, or it comes under regression or classification? You can put it. I'm asking that the example of predicting yield of a particular kind of crop will fall under the category of classification or regression. Thank you, ACT33. Yes, you're right. It's a regression. Yes, Shashiji, thank you. This is a regression. So similarly, like in regression, we're having the output is the real value, like predicting rain, predicting humidity, predicting wind, and predicting speed. So all that kind of where we are dealing with the real value, it will come up. We'll also see it through some example. And in unsupervised learning, you have seen that images. Okay, so we are just putting a request in Google, and it's giving us cluster. But you are having a non-label data. We are not aware about which particular variable or feature is driving to which particular. So here we are this kind of data comes in the category of unsupervised learning, and which is a part of machine learning, and machine learning is a part of AI. And under AI, machine learning, unsupervised learning is under the machine learning, and clustering is coming unsupervised learning. So you can see here again, you have to deal with these three kind of, and you are able to understand machine learning, and I'm going to demonstrate classification and regression in front of you right now. So, like example of regression is prediction of wheat production, prediction of rainfall, prediction of stock, prediction of uh, house price is again part of regression problems. Then classification problem, prediction of cancer, win prediction of Mr. Yogi in UP in third time, diabetic prediction and classification of email. And if you talk about clustering, the example are news, grouping of people on their similar hobbies, grouping of animals, grouping of customer based on their performance. You can see that we're having elite customer, we're having normal customer, prime customer. So we're having different kind of customer category, and they're availing different kind of service from their companies. I hope so far so good. So basic idea again, experimental data is there that we're using some machine learning model, and based upon that we are predicting or classifying something. So let's take example like I was talking about y equal to mx plus c. Okay, and here you can say that we are having four factor x1, x2, x3, x4, and output is that like suppose these are the four parameters, like how many rooms are there, is what is the size plot, primary location, etc., etc., and based upon that we are predicting something. And so we can write this particular things, this particular kind of experimental data in equation form while using linear model. So here you can say that y equal to m1 plus x1 plus m2 plus x3 plus like this. So ultimately you are able to extract linear equation. Let me take a very small example. Here I'm taking an example while using MS Excel. Here just write price and you write sales over here. Okay, suppose the price of brown bread. Okay, it is so this is the price. Brown bread is increasing, and the sales, suppose it is in lakhs. I'm just putting it two figure over here, like 65, and then so the moment companies increasing the price, and here we can understand many things from here. We can calculate correlation between these two values, and we can also establish equation that is y equal to mx plus c. Suppose if I increase price, my new price value is, suppose I'm fixing price 44, then what will be the sales? I want to understand this. So I'm going to put all this value over here in this particular equation. So I need value of m, that is slope. I need value of intercept, that is c. Okay, so in your MS Excel you can dig out these two values. So you can write slope. Okay, so known wise. Okay, these are known wise. Known wise matlab price. Sorry, known wise is our sale basically. Okay, so these are the sales is known, and with respect to its price, so this is slope value. Okay, and if we talk about intercept, again known wise matlab known sales, and known price. So now I'm just going to put this value in this particular y equal to mx plus c. So x is 44. So what will the sale? So here m is 2 multiply by 44, that is our x, new x, and plus intercept. So 67 million kind of will be our, we can predict. So this is very simple model. We are using linear equation and we're able to predict it. Class, are you getting me what I'm saying, doing over here? So this is very simple basic model I'm demonstrating in front of, that is a linear model in front of you. Even though we can use a direct formula, forecast. Okay, what is x value over here? 44. And what is non-wise? That is sale. And what is non-price? Just close it. You're able to see here. With the help of forecast and with the help of using this linear equation, we are predicting sales. And while using forecast method, which is again in the backbone of this particular equation is working. So you can even though understand this while using some graph. You can see here there is negative correlation between these two, because the moment you are rising the price, and here you just click over here and you can add trend lines. So this is the equation, and already we have extract the value of m, that is 2 in our case. This is 2, okay, minus 2, and similarly we have. So this is very simple way already things. So in machine learning, in the backbone of machine learning, you should have a good techno know-how of stats. Only then only you can develop more and more models. I hope this is clear to everybody. Sorry. Then this is another you have to predict. Already demonstrate in front of you that how to predict a particular output based upon some. So we have already having data like known y's are there, known x are there, and then we are giving a new x, and based upon that we are predicting the value of output. So in machine learning, these are some famous machine learning models: AdaBoost, EV, Net, Bag, Blockbuster. So sorry, BlackBoost, Bruta. But normally we in routine life we are using SVM and decision tree, LM. So these model are normally we're using. So now I'm going to demonstrate in front of you machine learning with some examples. So first of all, let us take a real-time example. When we were child, we have took a lot of our parents. They took us to doctor and they vaccinated us with the some many kind of medicines which can protect us from life-threatening diseases. So when we are reaching over there, that doctor is having a 5 ml or 10 ml medicine and shishi bottle, and through that particular bottle they are extracting that 5 ml 10 ml in their injection, and then they later on they inject to us. So so suppose that injection is 10 ml basically. Okay, if injection is 10 ml, and while extracting that particular medicine from that bottle of 10 ml, so it may be 9 ml, it may be 8 ml, and then doctor injecting us that, and then the effect of that medicine is okay. So result are good, but the moment the level of medicine like which was recommended 10 ml basically, but due to somehow like doctor is not that much expert, and he's not able to inject complete medicine. Suppose they are putting a 5 ml. In that case, that medicine will not effective on you. Okay. Now take the example of another, like we're having 1 liter bottle of the same medicine, and there is a nurse, okay, in government hospital. Doctor is recommending medicine to, and she is pouring medicine in her syringe. Sometime 5 ml, sometime 8 ml, sometime 4 ml, sometime 9 ml, sometime 12 ml, sometime 15 ml. So this is happening. But now we have to understand one thing. We are saying that if medicine is less than 5 ml, it will become ineffective. Okay. The moment medicine becomes 16 ml, it is life threatening for you. It will become dangerous for you. Okay. So the range of accepting a particular is that 5 ml to 15 ml medicine injecting in the body is acceptable. Okay, is acceptable. So we'll talk about this concept right now. Okay, again I'm taking this data. This is a classification problem. So this is a classification problem because the data is the response. This is basically why. Are you able to see this? The response RMSD is this is my output basically. So this is coming in numbers and in discrete number, not like continuous number. So this is a pure problem of classification. When your Y is coming in the form of discrete number, that problem is entitled for classification. Let me see another data set. Okay, this is data set for regression. So here you can see here, this is my A column. My data is in continuous form. So this data is entitled for regression. So I will play with these two example. Once we're having, and you can see here, here you can see here, we are having 16,382 records, and this particular output is in continuous form. So it means this particular problem is entitled for prediction problem, and this is pure problem regression where we can predict the value of this. So let's play with this data. So you can use many tools are available in the market, like you can use Python, you can use Rattle, you can use NIME as well. So it's not so much tough that people are thinking that these things are very tough. We have to learn Python, etc., etc. But there are some GUI based platforms are also available in the market. So right now I'm using for your convenience that instead of writing code and doing something, I'm just going to use a software package. It comes under RStudio. Okay. And while use here is a package, its name is Rattle, and I'm going to use Rattle software. So I'm just closing it for your convenience. And here again, I'm going to write this. So to run this particular package, I have to run this command library Rattle first of all, and then I have to call this function, this package, while writing Rattle. So it will start a new window. You just see here. So this is graphics user interface for me. Okay. And here I'm going to upload my data. And now I'm going to play with that data. So first of all, click on data and then upload the file. Okay. So here I'm going to upload the data. And first of all, we are taking a problem regression. And because in this, uh, we have to click on execute. You can see here, it is showing me there are 16,382 observations are there and 7 input variables are there. So far I have not selected any target value to predict any modeling. So first of all, I have to select my target. So RMSD is my target. Okay. And I have to divide my data into things, training and testing. So right now, out of 16,382 records, I'm going to use 70% records for training purpose, and I will test the performance of models on 30% data. So I divide my this particular data set in two parts: training and testing. And seed is 42. It means that it will start randomly from anywhere, and ultimately that so that will segregate this 16,382 data randomly in two blocks, 70% and 30%. So click on execute. So now you can see here again, we're having 6 input and the target is RMSD. And it is suggesting me regression model enabled, because the moment it is reading the value of my target cell, because data is in continuous form, in real form, then it is saying that this data is entitled for regression problem. So now next I'm just clicking. There are many more things are there. When we talk about data analytics, you can have descriptive analytics. You just click over here, you will able to understand that all the 7 parameter, what is their mean, median, mode and all third quartile. And you can also see the distribution while clicking on histogram. Okay, that how data is dispersed in normal. uh, One second. Okay, so we have to check out and in R you can see here that, so we can understand whether data is left skewed, right skewed, or normally like when we draw some when whether data is proper in bell curve. See, this is the line, and whether data is left skewed, whether data is uh, right skewed. So that kind of things you can observe. And here you can see that these data is not properly distributed over here. So statisticians people can make out more value from this. And even though if I want to know that what is the correlation all these 6 values with my output or among themselves, all the parameters, I'm just clicking over here, and here you can see that the correlation among these parameters. And even though you can see here, so most all the parameters are having positive correlation. So the correlation range is from -1 to +1. So all these values are when these colors are blue, it means all the values are, all the parameters are having positive correlation. So it means the parameter which is contributing in thing in this particular problem in this linear model, so they are contributing in positive manner. So now I'm just switching in between test, transform, cluster. I'm just clicking on model. Now I have to train. I'm going to use decision tree model, random forest, ADA boost, linear neural network. So already these are the models are available in Rattle software. You just click on model and click on all, and then click on execute. Then it is now all the models are getting training on 70% data. You can see here we had 16,000 something data, 16,000 382. Now just see here, it is mentioned over 11,467 lines are picked, and on that data we are training all this model, and this particular software took 25.57 seconds to compile this, to execute, and to train yourself. So next thing is that now we are going to understand which model is so right now we are using 30% data and testing that which model is observing, uh, predicting the right value as with respect to our real value. So click on evaluate. So here you can see this is predicted versus observed. Observed is our real value. So click on this and execute it. So in case of real value, you can, this particular software will like activate this PR versus OB, and it will draw the diagram for this. So you can see here, so, and I hope you are able to predict that from this particular image that which model is predicting more efficiently as compared to others. So here you can see that our actual line and prediction line is having a lot of gap, and this is related to decision tree, and this is random forest where you can see that the bubbles are very near, both lines are going near simultaneously. So you can see that by this image, it means this particular model is predicting very well. Is it clear? Now if you want to see that how much in case of number, let us click on score, okay, and execute this. So we have to store this value. So I'm going to store this value in meter is save. So now I'm going to use this value, okay, file, open, sorry, it was fast over here. File, open, computer, editor. So this was the result. Right now we have generated. This is a based upon 30% data. You just check out over here how many records are here. 4,915, which is 30% of our data set. So now what we have to predict? Actual value was this. Okay, this is our actual value. So this is decision tree, random forest, GLM is linear, and this is ANN, artificial neural network. So these are 4 different models we have used over here, and you can see here the value predicted by them. So here you can you can do 2 things. First of all, like accurate, which model is performing more accurate, okay, and this is I'm going to interlink this particular example with the example of healthcare, that is a nurse is injecting injections with some quantity, which is when they're injecting, it may be in mm, shortened with some mm or something. Similarly, when we talk about industry 4.0, then we are using over their machines which are interacting with each other, and when they are manufacturing something, then there are some thermostat cameras, IoTs, vision, etc., and with some prediction they are fixing something. So I'm going to correlate all these things, but first of all let us understand from these 4 model which model is giving more accurate result, okay. And based upon that model, I'm going to use that model in my industry 4.0 recommender system, and that particular model is going to be part of my machine, my robot, my decision maker recommender system over there. So for this, first of all, let us check out who's predicting. Let us assume this. If real observed value, okay, this is my equal to predicted value by a decision tree model, then write 1, else type 0, okay. And I have to take this mixed reference over here. So you can see here this value is 4.4 something and this value 2 point something, so this is not matching. So similarly I'm going to do this for random forest. So none of the model is not able to give the exact value, predict the exact value when the parameter was passed for testing to this model. Let us check out in this 30% record how many time which model predict. So you can see here, take the average. Sorry, I'm going to put here view phrase pan. Now take the average. You just see here the accuracy of decision tree is more, only 1%, and rest of model are failed in this. But when we're having, guys, this is to be like you have to note this thing. When we're having real value, it is not that you will have always, like in this case we're talking about that injections, okay. It may be that sometime it is 0.05, 4.12, so this kind of value is coming there. So this is and the range is 5 ml to 15 ml. The range is 5 ml to 15 ml. And how we are accepting this particular. So here we can say that minimum 5 ml, okay, maximum 50 ml. So what is the middle value? That is 10 ml. So what we are accepting, an error of plus minus of 5. So here in this case, the data we are getting here, now we are also using another concept over here, similar kind of concept, accepting error. Like when you're passing any lot, and so here instead of this equal to this, now what I'm saying here, the difference of actual versus, okay, the difference of actual versus this, okay, and its absolute value, okay, less than 5, in this case I should write 3, okay. If this value is less than 3, then I will accept it. If this value is greater than 3, the deviation is 3, then I have to reject that decision. So you can see here, so this the value predicted by R, and with absolute error, while accepting this error, okay, I'm accepting this particular. So now just see in the case of others. So in this case, you just see here, and this kind of knowledge will come with the from the experts. I will tell you I will explain with the other example. So right now, if we reduce the difference to, you just see here, now linear model is failing to. So now let us calculate its accuracy, okay, was giving more accurate. So right now random forest is giving me this accuracy. So in this case I'm going to use random forest model, okay, with the absolute reference. In this case I'm having a data set of wine, or you can say that let's have a data set of chocolates, and we're inviting experts or expert in telling the category of chocolate, and accordingly we're deciding something. Similarly, we're having a data set of wine, and in this case, data set number 3. Yeah, this is data set number 3. 1 second, class. Don't save. Am I having? Okay, open. Okay, so this is data set. In this case, we're having 4,898 records. So what happens in this case? A company which is in the business of wine, and they invite some expert and then offer them wine, a cup of wine, okay, and based upon their experience, they are giving the number, discrete number to that a particular glass. This belongs to fifth category. This belongs to four category. This belongs to five category. So on, three category, two category. So they're labeling it. So in this case, company invite expert, paid them huge amount, and offered them wine. They enjoy the wine. They took the hefty amount from the company, and ultimately, what they're giving us the number. So now we're having these 4,000 plus glasses, which and with labels, like label given, number given by them. The quality of the wine is 5 or something. Now we took that glass into the laboratory, and then we extract these 11 values, like how much fixed acidity is there, volatility is there, citric acid is there, residual value kya hai, chloride kitna hai. So all that kind of value we have extracted, and we made a data set in which we're having 4,898 records are there. So now I'm going to use this particular data set. And now I'm going to, now in future, I'm not going to invite any expert. Now I will just pass the value and my recommender system category of wine. And in nowadays, lot of companies, they are also manufactured artificial tongue. They are pouring a drop of wine over there, and then that artificial tongue is that much capable to predict the category or level of that particular wine. So this is happening nowadays, and it's also part of industry 4.0. When you're manufacturing something, and it is a part of that, you're pouring something, a drop over there, and you're fetching that data, and with the help of that data, you're updating, you're sitting somewhere else, and you're having that information. Okay, so right now in the plant, we are manufacturing this particular kind of level of wine. So class, now I'm going to upload this data. So this is wine, open, and execute. Yes, I have to overwrite. And now I'm going to divide my data again in training and testing, 70-30, and quality is my target. This is done. Now I'm clicking on models. Now I'm going to train all models 70% data. So now it's all the models are getting training. Next step is that which model is giving me more better accurate results, so that I can use that model in my machine, in my robot, in my artificial tongue as a recommender system. Okay, click on evaluate and execute. So again, click on score. I have to, so this is a sample related to your network. Okay, and I have to store this in network, save, close, don't save, close, don't save, and close, don't save. So close, don't save. Now we have to open. So this is data. This is test. This is a testing result from different models. So we are going to calculate which model is giving us accurate result. So this is our actual value or observed value, and this is predicted by these models. Okay. So now again, you can write here, if actual value, okay, equal to predicted by the model, then type 1, else 0, and you have to use mixed reference here. You can see here, in case of random forest, actual value is 4, and random forest is also predicting 4. So here now we have to see that which model is giving us more accurate result. So for this, we have to take the average result of this. So in this case, random forest is and convert into the percentage. So which model is giving us highest value? 68% given by random forest. So in this case, we can go for random forest, but this is very less prediction. So you can go for acceptable error, or you have to collect more data, increase your data set so that you can achieve the accuracy. So if we talk about using this kind of model in Industry 4.0, so I'm having a question: what is the name of the oldest company in the world? So this is from Japan. Its name is Congo Bhumi. Congo Gumi. It was 14 year old, but it was over occupied by Takamatsu Construction Group in 2006, and still the oldest company, which is operated by its is operating by its successors, and its 53rd generation is running this particular business again in Japan. Its name is um Koshu Nishiyama Onsen. So this is related to hotel industry. So this is the one of the oldest. So you can say construction and hotel industry is the oldest industry in the world. And if we have a glimpse of the past, in 1000 AD, the 50.5% of GDP, like world GDP, was controlled by India and China. By 1600, the GDP of India rise, but the GDP of China got down. 100 years later, China GDP fall again, and like up to 24.4. And by 1820, however, India's share fall by to 16.1%. And by 1870, it went down 12.2%, and now we are struggling to achieve 7.8 something GDP. So this is happening right now. And if we see that in India, pharmaceutical industry is given maximum billionaire, 137 billionaire. But pharmaceutical industry is so much old. From, you just know, just recall incident from Ramayana when Lakshmana was like Lakshmana needs some medicine, and then Hanuman bring the medicine from Himalaya. So that old is pharmaceutical industry, and so far we're having only 137 billionaire in this, and Adhar Poonawalla, and total net worth of this. But if you see about software and service industry, this is around 30-40 year old industry, and it is having maximum billionaire in India. 73 billionaires are in India. So now, if we talk about Industry 4.0, which is also using Web 4.0, where we talk about smart, we are talking about smart IoT devices over playing a big role. in manufacturing, in logistic management, in fixing the problem. So I will give you a lot of examples. So if we talk about industrial revolution, first of all, it's machine powered, and the machine were running with the help of water and steam. Then after electricity invention, we have seen mass production in industry 2.0. In 1963, when computer emerged, electronics automation started, and automation started over there. And now we are talking about industry 4.0, where cyber physical systems are working together. And in this industry, lot of technologies are working together. And in this, that a factory is talking to another factory, a factory is talking to a machine, sorry, a vehicle, and in a factory, machines are talking to each other. And even though, so I mean, nowadays, in this particular industry 4.0, data become a new fuel, and capturing that data helps company to increase their efficiency and increase their profitability. And to capture that data in industry 4.0, where data is being generated in between machine to man to man, so that kind of data is being generated, and you have to know that how to capture that data and how to capitalize that data into information, and so that you can have more better decision. And even though machine can take decision on their own, so training the machine to take when to take a right decision in right manner, so then machine learning is working in their backbone. So ultimately, we are learning from data, and we are employing machine learning based model, where we are trying to fix many problem of industry 4.0. So if we talk about technology which are playing a big role, so that's make it okay, that is social media, mobile, analytics. In analytics, big data is there. And when we talk of big data, so data is coming from machine, mans, and connectivity among these three: augmented reality, virtual reality, additive manufacturing, blockchain, cybersecurity. So all these are playing big role, and they are revolving around industry 4.0. And business is also changing, and we're see right now we are talking about web of things, where we are using a lot of IoT devices. And when we talk about IoT devices, so it means we are dealing with the millions of IoT devices which are having sensors and actuators as well. And industry is playing big role over there. But in industry 5.0, again, we are ready for that. Coming days, we'll have a lot of things in web of thoughts as well, where collective intelligence, artificial brain will work, and we'll have digital humans who are going to operate in the companies. So you can see the example of some startups are there. Core Neat Vision. Through this particular, an old person is able to see, a blind person able to see again. And we have seen example of like you just thinking about pizza, you're able to deliver something. So in coming days, man and machine will be so much capable. You will just think, and machine will behave in your production center accordingly. So how many IoT devices are working? This is my question, but lack of time, I'm just answering it. So we are expecting 29.42 billion IoT devices will work by 2030. So it means you will be going to live in a smart home. You are going to deal with smart vehicle. You are going to deal with smart cities. You are going to deal with the smart nation. So a lot of IoT devices are working over there, and which are facilitating, which are going to enhance your experience. And you will be part of digitalization. When we can, then we can say that you are living in a pure digital era. So countries who are leading right now in 4.0, so Germany, United States, Japan, China, and so far India is lacking, and we need a lot of work. तिवारी जी 5 मिनट कॉल बैक करता हूँ यार, एक मीटिंग में था. So So what kind of role it is playing? It is helping in predictive maintenance. So when it will be the next failure, and you can fix it earlier. You can take example of I will tell you more. A lot of companies are using it, but in Had Airways, they're sending their aeroplane for its service only when machine recommend that. Otherwise, and due to that, they're able to save a lot of money, efforts, and they're cutting the cost, and they're spending that money to enhance the experience of their passenger. So this is how companies are using it. So predictive maintenance is playing big role. So it is working in proactive manner, and machine algorithms are helping them from the data which they're collecting from sensor and from historical record. They're able to fix it earlier so that there will be no breakdown. Similarly, quality control and defect detections. Already have given you example that example you are we are accepting error, and in if some product fall in that particular category, acceptable range, then we are able to accept it, and otherwise we have to reject it. So machine learning model also helps us in identifying the defective products, so that we and they are using because I have given example of some label data, but they are using smart IoT devices in which they are having images and sensors. So nowadays, see, already have shown you this teaching machines. So we are using deep learning methods over there, and we are training our machines that based upon images whether to accept the product or reject the product. Similarly, like I was talking about artificial tongue, like you are producing chocolate flavor, you're producing wine. Based upon that artificial tongue, you're dropping something over there, and it is telling this particular fall in this category, or if that ranges, if that particular taste is beyond that particular recommended system, then it will reject and it will say it's defect. There is defect. It is going to help in supply chain as well. And nowadays all the docks, like where we are parking our ships in shipyard, and collecting container, etc., etc. So it is helping over there how to move the supply chain, how to balance the demand. And so I will tell you that how Amazon is taking the advantage of this. Smart manufacturing, I already told you about this. Then it's energy management. It is also sustaining. It's helping in sustainability. Robotic automations, and this is again where we need perfect precision. Then we'll not compromise with any acceptable error. We have to fix it with the precise value only, and otherwise sometime we also accept some error. So you are going to use machine learning in robotics and automation, inventory management, process optimization, customer personalization, and human machine interaction, data driven decision making. Cyber security is the main concern. You are running your machines based upon internet, and then there's a chance of that somebody may hijack your production line, and they produce something which is beyond your control. So we have to pay attention to cyber security as well. Product development, so new product is also suggested by coming under machine learning, and you are developing new product as per a prediction based upon market trends. Resource allocation, so that you can optimize, you can go for monetization, you can go for metaphor as well. So compliances with safety ML is also helping over there. So few companies which are using uh, uh, machine learning in industry 4.0, you can say GE is there, Siemens is there, Bosch is there, Caterpillar is there. They are using it in predictive maintenance and optimize production process and reduce downtime. Similarly, there are IBM company, which is a consulting company. They are using Watson and analyze sensor, which help in to streamline their manufacturing processes of their clients. Then Tesla, they're also using it for quality control. There is Amazon, which is a control that is using machine learning in optimizing logistic and warehousing operations. Then ABB as a company, which is using to enhance its manufacturing efficiency while using in robots and automation. John Deere, a tractor manufacturing company, which is coming in precision agriculture solutions. And Procter and Gamble is also using to streamline and optimize their supply chain and manufacturing processes. So if you see that academic lens, you just use Scopus and run this query, you will be able to see that Industry 4.0 terms coined in 1986, and lot of publications happening over there. And China is number one in publishing in this area. Best university is Platino di Milano, that is Italian university, and somebody's who interested to do some project or PhD or connecting with making some network. So these are the university where like a lot of research work fundings are available. You can go over there for PhD and PDF as well. So authors is this Graza, and 12,161 document are published so far. And journal, number one journal is sustainability, and then IEEE access. So you can communicate this kind of publication in this kind of journals. And if you talk about subject area, so it's more engineering and computer science centric. And even third number is business and management. Fourth is social science. So this diagram is also predicting that which term is leading to whom, and which will the trends. So it is depicting that Industry 5.0, where we'll have more smart and smart devices. So when a company is thinking about how to adopt Industry 5.0, so these are the factors which are pushing them. That first of all, they're asking why to use, whether it's useful, whether it's ease of use, whether it's compatible with our existing system, what is the complexity of Industry 4.0, tolerability, observability, relative advantage, cost of adoption, risk, and social influence, trust, user experience, organized support, training and education, top management support, regulatory and legal consideration, and interoperability. So all these are factors you have to consider when a company is adopting IO4. So they have to consider all these factors. Then these are the some model which is going to help the researchers, because these model are supporting previous variables while adopting while doing some research work, or to know that which factor is going to affect a particular kind of company while adopting Industry 4.0. So this is landscape, and these are a few risks. For the major risk is cyber attacks, and this is the ecosystem. A company should have good vision and strategy. They have to identify their stakeholder. They have to establish governance, collaboration, infrastructure and technology, data management, security, talent development, sporty policy, test bed, continue monitoring, and scaling the expansion. So these are few examples you can go through, and you will learn more about Industry 4.0.